Hi guys, welcome to today's lesson. We're going to talk about two important points. So the first one is rationalizing the denominator. This is a process in which you multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. For example, what that means is, let's say I'm given this fraction, square root of 5 over square root of 3n. My denominator is in the radical form, so what I need to do is rationalize the denominator because I do not want a radical in the denominator. So we're going to multiply this fraction by an appropriate form of 1, meaning for square root, I want to get rid of the square root sign, so I'm going to multiply the top and the bottom by itself. Because I know when I multiply square roots, this really becomes 9n squared because 3 times 3 is 9, n times n is n squared. But that means it's the same thing as this, which means it's 3n. So this cancels out. The two radicals cancel each other out, meaning my denominator is now 3n, right? And then the top, you just have to multiply. 5 times 3 is 15n. And then n is just n, so 15n is in the radical. And this is my final answer because I've rationalized the denominator. Here's another question. 2 over cube root of 9. So notice we have to rationalize the denominator because our denominator is in the form with the radical. And there is no perfect cube root of 9. So I'm thinking about a number where I can multiply the top and the bottom by some type of radical, which obviously has to be a cube root because we're dealing with cube roots, and get rid of the cube root on the bottom. If I multiply by cube root of 9, then this becomes cube root of 81. There's no perfect cube root of 81. Therefore, I should not multiply top and bottom by cube root of 9. Think about a number that you can multiply in order to get the cube root sign, the radical sign, away or disappear. So I'm thinking to multiply cube root of 3 on both top and bottom. By doing so, I know that my denominator will become cube root of 27. And again, you're playing with numbers to see which one has the perfect cube so that the denominator is rationalized. So I'm thinking this is a perfect number because I can take a perfect cube of 27. And then the top, there's nothing much you can do than just multiplying it because this one is outside the radical and that one is inside the radical, so you can't do much, just rewrite. Then I know 2 times cube root of 3 over cube root of 27 is 3 times 3 times 3, so 3. And we've rationalized the denominator. The second way to rationalize the denominator is to use something called conjugates. Conjugates are binomials that look something like these two. A square root of b plus c square root of d, where a, b, c, d are rational numbers. And the conjugate of this is just switching the sign right here. So vice versa, right? If I was given this binomial, the conjugate of that is using the plus sign. And for both of them, a, b, c, d are rational numbers. So these are conjugates. And we can use conjugates to simplify radical expressions that contain a sum or difference involving square roots in the denominator. So let me give you an example. So here's an example how to rationalize a denominator using conjugates. The direction will say simplify, and I was given 7 over 2 minus square root of 3. This is the radical expression in the denominator that contain a difference involving square roots and a number, right? So my conjugate of this would be 2 plus square root of 3 from the definition. What I need to do on top is also the same. I need to multiply top and the bottom. Okay, so now what I'm going to do is I would have to find and FOIL this because this is a sum and the difference pattern on the bottom. So let me rewrite that here. 2 minus square root of 3, and then 2 plus square root of 3. So I'm going to FOIL, use my method, the smile method right here. And then I have, let's just use this. 2 times 2 is 4. Square root of 3, a negative, times square root of 3, positive, is negative 3. The square root signs basically cancel each other out. And if you need help with that, that's just square root of, or negative square root of 9, which is 3. The negative is on the outside. Then we have here negative 2 square root of 3. And then we have positive 2 square root of 3. What happens here? The middle terms will always cancel out. When you're foiling conjugates, the middle terms go away. Okay, because they're the sum and the difference pattern. So then what I have on the bottom here is 4 minus 3. And then the top, all you need to do is distribute. So 7 times 2 is 14, plus 7 times square root of 3 is 7 square root of 3. And then you just have to simplify. 14 plus 7 square root of 3. Can't do much there. And then you have a 1. You don't really need to put a 1. So the answer is 14 plus 7 square root of 3. Here's the next question. And it's solving a real life word problem. The distance d in miles that you can see to the horizon with your eye level h feet above the water is given by d equals square root of 3h over 2. How far can you see when your eye level is 5 feet above the water? Any word problems, I would like to underline something that may be important in order to solve the question. So distance d in miles that you can see, and eye level h feet above the water is given by this formula right here, probably very important. How far can you see when your eye level is 5 feet? So basically, we're going to start off by rewriting your formula, given formula. Then I'm going to substitute this h with 5 because it says that your eye level is 5 feet above the water. And h is defined as your eye level, h feet above the water. So if I can rewrite this, is equal to 3 times 5, right? H is 5 over 2. All I need to do is simplify. So 3 times 5 is 15 over square root of 2. And I noticed I broke those two, the fraction, into two radicals, numerator and denominator. Then I will need to apply rationalizing the denominator because I have a radical on the denominator. So I'm going to multiply by square root of 2. So this portion becomes square root of 4, which is the same thing as 2. So my denominator is 2. And then here you have square root of 30. And this is about approximately 2.74 miles. That's it. Last question of today's lesson is another word problem. The ratio of the length to the width of a golden rectangle is 1 plus square root of 5 to 2. The dimensions of the face of the Parthenon in Greece form a golden rectangle. What is the height h of the Parthenon? Length of the face is 31 meters, and as you can see, I drew a rectangle, or it's the golden rectangle, and the length is 31 meters, and we're looking for the height. So notice I drew underlines on the important things. So the ratio is important, length to width, and we're going to compare this golden rectangle with the given dimensions. So we're finding the height of the Parthenon. We're going to set up a ratio. We're given this ratio. So we're saying it's length to width. We know the length of the Parthenon in Greece. So 31 over, we don't know the height. So we're going to basically cross multiply. And we get 31 times 2 is 62 equals h times 1 plus square root of 5. I'm going to look for h, so I would have to divide both sides by 1 plus square root of 5. Then these two will cancel out. Then I'm going to be left with, I'm going to write it right here. H is equal to 62 over 1 plus square root of 5. I need to make sure that I rationalize my denominator. So I will need to multiply the denominator by its conjugate. So the conjugate is the opposite sign, 1 minus square root of 5. If I do on the bottom, I have to do the top also, multiply top and the bottom. Then I'm going to FOIL the bottom and then multiply the top. So 62 distributes. So I have 62 minus, so 62 times negative square root of 5 would be just 62 square root of 5. Over, I'm going to FOIL these two. So watch carefully. Let me just change the colors. Right here, that's what you're doing. And notice the middle terms will always cancel out. And we've discussed this from the previous example because we have square root of 5 times 1 is square root of 5, and then 1 times negative square root of 5 is negative square root of 5. So the middle term cancels out. What we need to worry about is this and that. So we have 1 right here on the bottom minus square root of 5, and then negative square root of 5 will become negative 5, which means I have 62 minus 62 square root of 5 over negative 4. And when you put this into the calculator, you will get about 19.16. So about 19 meters is your final answer.